The first postulate of relativity, the laws of physics are valid in all inertial reference frames. Now, this sucker has a name, so of course it's important, but in order to understand it, we have to understand what is meant by this, inertial reference frame. So first off, let me just say that this is often referred to as an IRF. That's the acronym we use. So when you see that, it means inertial reference frame. And what matters here, or I should say what defines an inertial reference frame, is that the acceleration is zero. Now, you might be wondering, yeah, okay, but what's a frame? I mean, what do we mean by reference frame? So really, that's anything. It can be a person, it can be an animal, it can be a car, it can be a plane, it can be a spaceship, a planet, a star. It doesn't matter. It doesn't matter what object or abstract frame we're talking about. If it has an acceleration of zero, then it is referred to as an inertial reference frame. So remember, to have zero acceleration, that means you can't be speeding up, you can't be slowing down, can't be changing direction. And the idea is that any observer in any inertial reference frame will come up with the same laws of physics. Now, first off, this idea was not unique to Einstein. Einstein, of course, came up with relativity. He's not the first one to have this idea. Really, this idea stretches back to probably the beginning of our species. Certainly nobody was thinking that the laws of physics in Europe were different than the laws of physics in Australia. Okay? So all that's been done here is that's been codified. We've written it down, we've brought it into our collective conscious, but this was something that everybody essentially had been assuming all along. And it's important because when we come up with our laws of physics, when we say F equals ma, when we say that energy must be conserved, momentum must be conserved, we're saying that doesn't just matter here on Earth or in our solar system, it also matters in the Andromeda galaxy. It's also true there. It's also true in all the galaxies that are unnamed, no matter how far away they are from us. The laws of physics are the same. And so that's why we feel confident in making assumptions, why we make inferences about what's going on out in space. Based on what we see, we say, well, that must be hydrogen gas over there, or that star is 4 billion light years old. How do we know that? Because we're assuming the laws of physics apply there as well as they do here, and based on our observations, based on our knowledge and understanding, we're able to draw those conclusions about things even though they're not here. So this is the idea, and this dovetails right into the second postulate of relativity, which actually isn't a postulate, but I'll talk about that in that.